actually kind of want it shorter.
Morning, Casey.
Good morning.
All right, let's get started, shall we? Open up the 3D Eclipse lab. That's what we're going to talk about today. So
Look at Grant, man. So inspirational. What a legend.
okay. So last I looked, and that was like 10 minutes ago, you were supposed to have the prior knowledge and the gizmo warm-up done. And last I looked, let's see, we only had 1, 2, 3, 4, 5, 6, 7, 8 of you that had done that.
I finished mine 5 minutes ago.
Oh, too bad. I looked at 10. All right. So, have you ever seen an eclipse? Big yes?
The 2017 one was the day before my birthday.
Really? All right. And then just describe what you saw there. What did it look like? What type of eclipse was it? Was it a
Lunar.
solar or lunar?
Solar.
Solar. What did it look like? What did it look like?
There was a dark spot and a ring around the dark spot.
Okay.
There was the moon in the sky, and around the moon, the light from the sun shone around it.
Actually, a dark spot.
Okay. Okay, and this was just an opinion, right? About how often do you think eclipses happen? What'd you put? Someone share? Hayden, what'd you put?
I put like every 1.5 years.
Okay. You could have said basically anything you wanted to on that one. Once a month, once a year, once a week. All right, Gizmo warm-up. If you see a two-dimensional image of the Earth, it's going to look like this. A three-dimensional image is going to look like the bottom one. All right, so set simulation slider to a middle value and click play. So open up the Gizmo. Oh my gosh. Did I click that? So let's see. middle value, and click play. Somewhere in the middle. And describe the motions of the Earth, Sun, Earth, and Moon based on the top view. What do you see in the top view? Anybody?
The moon, Earth, and sun are lined up.
Okay. Yeah, and by that top view, it looks like, I mean, we might have an eclipse every month. We know the moon goes around in like every 29¾ day or so. So, you know, we might have an eclipse occurring every single month. Okay, click reset, click play again. This time focus on the side view. What do you notice? So now we're gonna just reset it and we're just looking at the bottom rectangle. And what do you see? Anybody? Danny, what do you see? What do you notice about the moon's orbit? Danny?
It looks like it's going around at like an angle around.
Okay,
the
yeah, it's like a kind of a tilted orbit. Okay, activity A, click reset. Under shadows, select the moon angle to 0. Okay, there are two parts of the moon shadow. Umbra is the central darkest part. Penumbra surrounds the umbra. An observer in the penumbra only sees part of the sun. Only the umbra is shown in this gizmo. Click play and then pause when the moon is directly between the earth and sun. If you go too far, you can click the back button to stop. So, oh my gosh. Hey, what do you notice about the moon's shadow? Ethan?
It's kind of going straight towards the Earth.
Okay. Kind of hits the earth, strikes the earth. Okay, under view, select earth. What do you see? Sam, what do you see in that?
I see that the shadow changes path throughout the year.
Okay. Okay, a person standing in the moon's shadow will experience a solar eclipse. During a total solar eclipse, the entire disk of the sun is blocked out by the moon. Observe, set the simulation speed to a lower setting. Click the back button until just before the moon's shadow crosses the Earth's surface. Click play and observe. So we want to go to a lower setting. And click reset. Okay, click play and observe. Let's see what we notice here. Okay, Eli, what do you notice?
Can you replay it again, please? That it moves from like the middle or bottom part of the moon to the like top, kind of.
Okay. Okay, the path of the moon's umbra traces across Earth's surface is called the path of totality. What will you see if you were standing in the path of totality? Trey, what would you see?
I didn't get anything done on this.
Okay. But if
Dark.
we just look at that, if you were standing on Earth,
You'd see dark.
what would you actually experience?
Dark.
Well, since Braden is Trey, Doug, I guess.
Yeah, well, what's that called? What are we experiencing?
Dark.
Total,
Dark.
a total,
Eclipse?
yeah, what type of eclipse? You got two choices, solar or lunar.
It'd be solar, wouldn't it?
Yeah. Okay, click reset, set the speed to a higher setting. Use the gizmo to determine the dates of the first 6 solar eclipses of the year. Okay, so there's one, January 10th, or yeah, I think it has to be January 10th. We'll continue till we see the next one. Here it comes. February 8th. Coming around again. March 10th. April 9th. May 8th. Is that 5?
Yes.
And June 7th. Okay, Grant, can you read back those 6 dates?
I have. Sorry, I lost my spot. January 15th, and then I got February 5th, March 2nd, April 4th, May 3rd, and June 1st.
March what?
2nd,
April 4th.
yeah, and May 3rd
And the last one?
is June 1st.
Hey, Corbin, do you think they happen as often as this sim is showing?
No.
No. And why not?
It's because they don't align in the exact same spot every time, every month.
Right, and as we saw from the beginning, the moon's orbit is actually tilted, isn't it? Hey, explore, click reset. A solar eclipse does not occur every month because the moon's orbit is tilted at 5.14 degrees relative to the Earth's orbit. To model this, set the moon angle to 5.1, play the simulation until January 9th, and click pause. Reduce the speed and click play. Moon's angle. Okay, then we're gonna reduce the speed here. Okay, what do you notice about the path of totality now? Let's ask Taylor. What do you notice, Taylor? Last time it crossed almost the entire Earth, right? Now the path of totality is what?
It's getting lower.
Yeah, it's much smaller path, much less distance. Right? Okay, advance the simulation to February 8th, and again, play the simulation at a low speed. Do we have an eclipse? Does the umbra cross the Earth then? Right, so February 8th. This is about 1 month later when we had an eclipse last time. Does the umbra cross the Earth's surface at any time? Didn't hit it, did it? Okay, in this situation, a total solar eclipse will not be visible from any location on the Earth's surface. Record. Use the gizmo to find the dates of the next 3 solar eclipses. Be sure to check carefully whether the moon's umbra actually crosses the Earth's surface and record those dates. So now we want to make sure that we're want to see that crossing the surface. Missed us that time. Nope. Getting closer. Okay, so June 7th. Like, what's another date? Can you find the next date, Evan? Still can't hear you.
July.
What do you got?
Oh, July 6th.
Okay. Okay. And third date, Caden, what do you got?
I had one on January 7th, I think. Before those two.
For these two?
Or sometime in January.
Okay, yeah.
January 9th, I think.
But wasn't that the one they wanted us to look at, or no?
Yeah, but I didn't know if they Well, if we could count that as one of them.
Well, it said the next 3.
Oh. Well, I guess not.
Yeah, here's the simulation until January 9th. So let's not count January 9th.
Okay.
So what would be the one after July 6th? Anybody find that one?
I found another one on December 1st.
December 1st? There's the poem we found earlier. That's next month. Now, did it hit us there? Doesn't, does it? Close. There we go. Yep. December 1st. Okay, do you think this frequency of solar eclipses is more realistic? Lennon?
Not really, because it isn't like, it doesn't happen that many times in 1 year.
Yeah, it's laying down up there because it's too tall. Okay, on your own, experiment with different moon angle values. How does angle, so as you increase the angle, what happens to the number of solar eclipses? Did you get more solar eclipses or less solar eclipses if you increase the angle?
Less.
Less, right? We increase that angle, something like that. I mean, you're hardly going to ever see that thing. It is up there somewhere. It's in the bottom shelf. Okay, on your own, return the moon angle to 5.1, increase the moon distance to 1.5. How does increasing the Earth-Moon distance affect the occurrence of total solar eclipses? Bring that back to 5.1, and we'll bring that to 1.5. Okay, we get one on May 12th. Missed us there. And then November 5th. So what does it do?
I had that they didn't happen because the shadow couldn't reach the Earth.
Well, it might still happen. It just is going to be less occurring. And plus, if you noticed from when we set the moon distance to 1.5, the shadow it cast was even smaller, right? So, you know, less and less people are gonna, you know, be able to see. Okay, lunar eclipse. So you should be able to get that done and follow the directions on that. I'm gonna let some of you go here. Let me stop share.